For this problem, we are required to solve for its general solution. From its form, we can see that it is a Riccati equation. Riccati equations usually are given a particular solution, which is, for example, u is equal to 1. To solve for it, we have to do this substitution, y is equal to u plus 1 over z. By manipulating this substitution, we can transform this equation into a linear differential equation. And since we are given the value of u is equal to 1, we can use it to get y is equal to 1 over z. By manipulating it, we can get z is equal to 1 over y. This we can use it for later. By taking its derivative, we get y prime, which is equal to negative 1 over z squared multiplied by z prime. Now substituting it to the original equation, we get this equation, negative 1 over z squared z prime, which is equal to z multiplied by 1 plus 1 over z squared plus 1 minus 2x multiplied by 1 plus 1 over z plus x minus 1. By doing some manipulations here, we get this form, and by distributing it, we can get with the solutions here. So by distributing x in this term, we get x plus 2x over z plus z over x over z squared. And for this term, we rearrange it so that we can get negative 2x minus 2x over z plus 1 over z. For the last terms, which is x plus minus 1, we get x minus 1. We lay out this like this so that we can easily cancel similar terms. So we can see that the x's can be cancelled, that 2x over z can be cancelled, and 1 can be cancelled, which leaves us with negative 1 over z squared z prime, which is equal to x over z squared plus 1 over z. By multiplying it by both sides by negative z squared, we get z prime, which is equal to negative x multiplied minus z. Now, rearranging the terms, we get z prime plus z is equal to negative x. Now, this form is clearly a linear differential equation. To solve it, as described as earlier, we solve for f uppercase x, which is equal to e to the integral of whatever is the coefficient of z here, dx. Since we only have positive 1 here as coefficient, we only get e is equal to integral of dx, which when evaluated will give us e to the x. Substituting it to the form for the linear differential equation solution, we get e to the negative x multiplied by z is equal to the integral of e to the x negative x dx plus c. Now, since we can't get the integration here by e to the x multiplied by negative x dx, no matter whatever substitutions you do here, we see that there's a e to the x term here, so we just multiply 1 over e to the x on both sides of the equation to get z, which is equal to negative integral of x dx plus c over e to the x. Now this can be integrated to get z, which is equal to negative x squared over 2 plus c over e to the x. Now substituting the value of z here from what we've shown earlier, we get 1 over y minus 1, which is equal to negative x squared over 2 plus c over e to the x, which is the final solution for the given problem.